Hey guys, welcome back for another chemistry lesson. In this video, we are going to talk about the electromagnetic spectrum. So, light energy is specifically electromagnetic waves, and visible light that we see is only a really tiny fraction of all of the wavelengths of light. And all of these wavelengths of light together, we call the electromagnetic spectrum. Generally speaking, the shorter the wavelength, the higher the energy. So radio waves have the lowest energy because they have really big wavelengths, like kilometers long, potentially, wavelengths. And then gamma rays, which are incredibly short waves, have the highest energy. This is the kind of like damaging from nuclear weapons type radiation that you don't want to be exposed to. Right? So shorter wavelength, which means higher frequency light has higher energy. High energy electromagnetic radiation can potentially damage biological molecules. We call that ionizing radiation, and so that would be like gamma rays and X-rays and things. But gamma rays are the big ones, the ionizing radiation. So here is the electromagnetic spectrum. As you can see in this image here, we've got our visible light spectrum on either side. We've got infrared, which is longer wavelengths, and ultraviolet, which is shorter wavelengths, IR and UV. And then beyond that, microwaves, radio waves, cell phones, AM, FM, TV waves, X-ray, and gamma rays. So again, once we get beyond visible light, this is the damaging stuff. Gamma ray is the ionizing radiation, but UV and X-rays can also do damage to like your DNA. So this is why you can't get a whole bunch of X-rays in 1 year. They always ask you how many you've had, like when you go to the dentist, because it can do damage. Likewise, this is why we wear sunscreen, because UV light can do damage. Not in the same way as gamma rays, but still damaging. And then infrared radiation is literally heat. So this is where like thermal imaging cameras come into play. And then here we go. So you will see the electromagnetic spectrum alongside a scale that shows you the frequency. I don't know why this should not be there. I don't know what that's about. Frequency is V. This is, I'm sorry, this is the first time I'm noticing that this is wrong. Frequency, which is the like cursive V looking thing, is measured in hertz, which means per second. So our frequency from low frequency, like 1,000, 2,000 per second, all the way down here, up to 10 to the 24th per second. We're talking ridiculously many per second. And all that is how frequently a wave passes a given point. So if you think about standing out in the ocean, how frequently a wave crests at your body, right? That is the frequency. Except now we're talking about tiny waves that are not water, right? And then our wavelength, which is lambda. Again, this is the first time I've ever seen. This is bothering me. No, not this. Not that. No. X. Okay, so wavelength, which is lambda, is measured in meters. And on the radio wave, we're talking about 10 to the 5th meters. That's 10,000 meters, like 10 kilometers length, so miles long potentially. And then our visible light is in the 10 to the 6th, 10 to the 7th range here. We generally speak about it in nanometers though, which is why this additional scale here, nanometers. And then gamma waves are very small, 10 to the negative 15th type scale potentially. So you'll usually see it all in one picture together, like on this slide. All right, light is a continuous spectrum, so there's a video, I'll put it here, that has the discussion about the spectrum and what it means to be continuous versus non-continuous. So if you haven't watched that video, go watch it here. And then here we can see just a couple of uses that we have for things outside of the visible spectrum. So on the top right hand corner, you see this funny looking picture. This is how we use thermal imaging, right? The like darker reddish color is hotter, and then the blue is cooler. So we can actually, if you have the right tools, see what is present based on the heat that it's emitting. So this is like night vision is sometimes thermal. They sometimes use thermal imaging, and then just, like that. And then our other use that I'm going to talk about is that high energy radiation that I said can damage biological materials. Well, sometimes that's a good thing, because sometimes we want to damage biological materials like cancers. So we can use high energy radiation to kill cancer cells.